In this video, we're going to learn another way to solve quadratics, this time using the quadratic formula. Now, I want to remind you guys what a formula is. A formula is any expression where you can substitute in values to give you to calculate some result. Let's think about some examples of formulas that we're used to. We've used formulas like the area of a rectangle or of a triangle before, so length times width. So if you know your length and your width, you can plug those in and solve for your area of a rectangle. We've also learned a couple more complicated formulas this year, like the formula for slope, which is not this. It is y2 minus y1 over x2 minus x1. So we have a lot of different formulas that we've used in linear functions, in geometry we use a lot of formulas. Now we have a formula that can tell us the solutions or those x values for our quadratic equation. So if you have some quadratic, so maybe you have something like 2x squared plus 3x minus 6 equals 0, you can figure out what your two answers are using our quadratic formula. Now, our quadratic formula follows a process to be able to use it effectively. Our first step is that we need to move terms so the quadratic is set equal to 0. So this is something we had to do when we were factoring or graphing, is we had to get all of the quadratic part on one side and 0 by itself. We also need to identify A, B, and C. We also use this when we were graphing, or when we were factoring. But now, instead of just stopping there and then factoring, we're going to substitute A, B, and C into our formula. After we substitute it into the formula, we just have to simplify, simplify, simplify. So just like when we would have slope and then we would simplify the top and simplify the bottom and then see if we could simplify the whole fraction, we're going to do the same thing here. We start by simplifying that radical if we can, we simplify the denominator if we can, and then if it's possible, we'll split it into two expressions and simplify again. I'm going to show you an example where we can do that and show you an example where we leave it in this slightly more complex form. So our quadratic formula is a little bit complicated. So I gave you the math expression and then I also gave it to you in words. So x equals negative b plus or minus the square root of b squared minus 4ac, or 4a times c, all divided by 2 times a. Now I know this is a lot, but I want to point out a couple of things. The first, we have that plus or minus. Just like when we were solving by square roots, we have two possible solutions to most quadratics. And so if we have two solutions, we want to show that by having a positive and a negative for that radical. So it's just like when we solved by square roots and we had two numbers that might give us the answer. You also see this negative b. That negative b means to change the sign of b. So if b is positive, it's going to be negative over here. If b was negative, though, it's going to become positive. So we're changing the sign of the number. So our quadratic formula is kind of complicated, which is why I have this song that is linked to help you kind of memorize it and have a way for it to all go together in your brain. The most common mistake that students make when they use the quadratic formula is that they don't remember it correctly, and so they make a mistake as they substitute in. So having something to help us remember it can be helpful. So we are going to do some examples to help us use the quadratic formula. And in those examples, I'm going to use this graphic organizer because this graphic organizer helps you substitute in your values, which is the biggest area of difficulty for a lot of students. Now you notice that they show the letters A, B, and C, but they also give you shapes. So you have another way to remember where you're putting those variables. And I've also copied our process again so that we can use that to make sure we're following every step. So our first step is to move terms so the quadratic is set equal to 0. Equal to 0. I do see equals 0 over here, so our first step is done. Our next step is to identify A, B, and C, which are our coefficients. So remember that word, coefficients. In this problem, I'm going to copy it down into these boxes so that I can find A, B, and C. So A is going to be 4, B is 11, and C is negative 20. You notice that I bring that negative sign with the C value so that I can have it in my formula where I need it. So we've done step 2. For step 3, we are going to substitute A, B, and C into the formula. And when we do this, we need to make sure that we always are using parentheses. In this case, our shapes are acting like our parentheses. So B we said was 11. B is 11 again, minus 4 times A, which was 4, and C, which was negative 20. You notice the negative sign still is there. And then I have an A over 2A, so A was 4. So now we've done step 3. All that we have left to do is simplify as much as we can. So to simplify this, I'm going to start by simplifying my radical. To simplify the radical, I'm going to take my calculator and put 11 squared. So I'm going to do parentheses 11 squared minus 4 parentheses 4 parentheses negative 20. You notice I'm using my negative sign, not my minus sign, because the 20 is a negative number. Now you notice every number that I substituted in is in parentheses to make sure that my calculator knows the order to do all of its steps. If I hit enter, I get 441. So now I'm going to get x equals negative 11 plus or minus the square root of 441 over 2 parentheses 4 is 8. You notice that the 441 is still in the radical. I do not do the square root until after I've simplified the number inside because I don't want to get a decimal if I either want it to stay as a radical or become a whole number. So now we can see, can we simplify the square root of 4? Can we simplify the square root of 441? So I'm going to take my calculator. If I knew this square root, I would just use what I know, but since it's a big number, I'm going to take my calculator, put the square root of 441, and I get 21. So I can rewrite my equation as x equals negative 11 plus or minus 21 over 8. So now I took the square root of 441, so there is no more radical. And we've simplified everything as much as we can, so we did step 4. Our last step is, if possible, split it into 2 expressions and simplify. So because I got rid of my radical, I can split this into 2 expressions. The first one is negative 11 plus 21 over 8. And the second one is negative 11 minus 21 over 8. Remember that plus or minus is showing us that there are 2 different numbers. So I'm going to take my calculator, go alpha y equals, so I can get my fraction. Negative 11 plus 21 over 8 gives me 5 over 4. So that is one of our answers. And then I can do second the enter button to get the entry again and just change that plus to a minus sign. And we get -4. So our two answers to this quadratic are 5/4 and -4. I know this looked like a lot of work, but most of it was done using our calculator. We just wanted to show our work so we could remember what we had done. Let's do one more example. In this case, our quadratic is 9x squared equals 4 plus 7x. In this problem, it is not set equal to 0. I don't see a 0 here. So I'm going to subtract 4 on both sides, and we get 9x squared minus 4 equals 7x. And then I'm going to subtract 7x on both sides, and we get 9x squared minus 7x minus 4 equals 0. Remember, we have to get it equal to 0 first if we're going to solve it. Next, we are going to identify A, B, and C. A is 9, B is -7, and C is -4. And we are going to substitute A, B, and C into our formula. You notice that I'm going to keep the signs here. So I have minus -7, another -7. A is 9 and B is -4, and A is 9 again. So you notice that every time I'm keeping the signs with it. So now we're going to simplify as much as we can. Minus a negative, so that gives us +7 plus or minus. And this is where I take out my calculator again to simplify the radical. I'm using parentheses and using -7 parentheses squared minus 4 parentheses 9 parentheses -4. You notice I do it all in one line. I do not have the radical. And I get 193. So we get the square root of 193 all over 2 parentheses 9 is 18. So we've done step 4. Remember, I did minus -7 to get the +7, and then I did everything under my radical in my calculator to get 193. Our last step is we want to see if we can simplify this more. So I'm going to start with the square root of 193. But when I do the square root of 193, I get a decimal that keeps going. So I know that I can't simplify this that much. So I am allowed to just leave my answer just like that because I can't simplify it. On the other problem, we had to break it down more because it could be simplified. And that is how we use the quadratic formula. The biggest thing that I want to emphasize, you need to know your formula and you need to use parentheses. If you don't use parentheses, your calculator might not understand what you're asking it to do. Thank you.